Okay guys, so this is a video that's all about the conditions. In talking to other stats teachers and trying to speculate on what the questions are going to look like, it's unlikely that they're going to take one part of a question and say, do a confidence interval, do a significance test. But they are probably, in some of those parts, going to break it down and talk about the conditions. And one of the people that I look up to in the stats community said he wouldn't be surprised if they had you explain why they have those conditions. So this video is about the conditions. Okay, it's about the conditions for inference, which means when we're doing our 4-step process for a confidence interval, for a significance test, whether it be for proportions or for means, or like in chapter 10, when it's a confidence interval for the difference in two proportions, or a significance test for the difference between two proportions, you have to have these conditions. This is in the plan part. When we do state, plan, do, and conclude, the state part, you name your test, okay? Well, the state part, you kind of reword whatever it is they're asking you for, okay? And make sure you put it in context. So if they're doing a 95% confidence interval for the proportion of people who like pizza, which would be very high, don't say, I'm going to do a 95 confidence interval for proportions, okay? That's not your state. Your state would be, I am going to construct a 95% confidence interval for the proportion of the true proportion of people who like pizza. Make sure you put your context into your state. Now, when you name your test, you don't need context, okay? So if you're doing a one sample Z interval, then that's what you say. A one sample Z interval for proportions. Okay, if it's a confidence interval, you have to say interval. If it's a significance test, you have to say test. If you make a mistake with naming the test, they're going to take you down. They're going to bring you down from an E to a P or from a P to an I. So you have to be very careful when you do that naming test part. Okay, so in your plan or in your state, somewhere in there, you have to name your test. So after you name your test, okay, or name your interval, whatever you're going to use, Z or T. Z goes with proportions, T goes with means. We've spent some time talking about that. I'm hoping that you want, let's talk about it again. Okay, so if you're talking about proportions and you're doing intervals, a confidence interval for proportions, or you're doing a significance test for proportions, then you use Z. Okay, if you're doing a confidence interval for means, okay, or you're doing a significance test for means, then you use T. And the acronym that they use is they say ZAP the tax, okay? Z with proportions, T with X bar, which is a sample mean, okay? So we'll spend a whole nother video probably talking about all the different symbols and making sure you don't mix up your symbols. But for now, we're talking about the conditions and we're thinking of the plan section, okay? So if it's a one sample Z interval, then that's what you say. One sample Z interval for proportions. If it's a two sample Z interval for proportions, okay, that's another thing you can say for your test. And we'll go through and we'll do examples of those. Okay, so once you do that naming the test part, now we get into our conditions. And what you have to remember is R, N, and I. Okay, R stands for random, N stands for normal, and I stands for independent. And I've broken those down on this sheet. This talks about what we do for it. And then if they ask you on this test, why do you have the normal condition? Why do you have the independent condition? Why do we have a random condition? Then the reasons are here, and we're going to spend time on this video talking about them. So let's deal with R first, okay? So R stands for random, okay? And a lot of times it's going to state that. It's going to say right in it, it was a simple random sample, okay? So you still have to restate it in your conditions, okay? If they ask you to do the conditions, you would say, it states that there was a random sample, period, okay? You don't have to get into all different types of things with that, but normally that's what they're going to do. They're going to tell you it. They're going to state that. Now, why do we have the random condition? Well, the reason we have the random condition is so that our results, our data, is going to be something that we can depend on. That's something that is going to make sense. Okay? Random samples give us unbiased data. Okay? Random give us unbiased data. Okay? And if something's not a random sample, then we really can't infer anything from that. We can't learn anything from that unless it's a random sample. So the reason we have the random sample is to get unbiased data, and so that we can infer, okay, or we can make inference, okay, about a larger population. Okay, so that's the reason we have the random condition. So we have unbiased data. Okay, random samples will give us unbiased data about a sample. And so that we can take our results of this inference, results from the confidence interval, results from the significance test, and we can infer about a larger population. We can talk about our sample in terms of the population. Now, sometimes the question will say, well, what group can you infer? What's the population that you can infer? And let's do an example. Let's say that there was an SRS inside this problem, an SRS of males in Massachusetts were asked if they liked pizza. Okay? And so at the end of the question, they say, okay, so what can we infer about the what population can we make inference about? Can we make statements about? Can we make it about all men? Can we make it about all people? Well, the answer is we can infer the population that we can infer about, the one we can set up a cause and effect is males in Massachusetts, because that's what our sample was. So whatever the random sample came from, if it said people in Massachusetts, then that's who our population is. That's who we can say our confidence intervals about, or our significance test. So it is important what they say in terms of what inference that we can make. What can we infer? What can we say about? The whole point about statistics is we're trying to learn about a population. What population did we learn about? The one they explained. Okay, so can I say that our data from this, our confidence interval, would work for all men in the United States? No, because our sample was from men in Massachusetts. So that's what we can make inference about. Okay, so that's our random one. Then we get to the normal one, okay, and it has all the information here. So we'll do normal with proportions first. So if you have proportions, we have to do n times p and show that's greater than or equal to 10, and then n times 1 minus p and show that's greater than or equal to 10. Okay, so you would do both of those out. N is your sample size, times p is your proportion. Now, if it's a confidence interval, you have to use p hat, okay? So if it's a confidence interval, you use p hat. But if it's a significance test, okay, if it's a significance test, then we just use n times p. Now, the reason we use p hat here is because we're trying to learn what the true p is. If they tell you what the true p is, like a significance test, then you just use that, n times p. So n times p greater than or equal to 10, n times 1 minus p greater than or equal to 10. Up here, if it's a confidence interval, we have to use the p hats, and that goes whether it's a 1 sample or if it's a 2 sample. Now, if it was a 2 sample, this is for 1 sample, okay? If it was a 2 sample, then you have to do n1 times p1 and show that's greater than or equal to 10, and n1 times 1 minus p1 and show that's greater than or equal to 10. and then n2 times p2 and show that's greater than or equal to 10, and n2 times 1 minus p2 and show that's greater than or equal to 10. Again, if it's a confidence interval, these are going to be hats. If it's a significance test, then it's just p. Okay? So those are for proportions. Now for means. For means, we just look and we want n to be greater than or equal to 30. If it's two proportions, then we want n1 to be greater than or equal to 30, and we want n2 to be greater than or equal to 30. Okay? Now, if n is less than or equal to 30, then we have to look at a graph, and we have to look at a graph of that data. Now, they said they're not going to have you make graphs, but if they have a graph of that data, and they say, you know, is this going to pass the normal condition? Then we would say, you would look at it, and as long as there's no strong skew or outliers, then it's okay to use, it would pass, quote, the normal condition, okay? So after doing all of this, you would say something like, since n times p hat is greater than or equal to 10 and n times 1 minus p hat, but putting the numbers in there, we can use the normal approximation. Now, that satisfies the condition. If they asked you why do we need the normal condition? And the whole point of that is because we use this stuff, okay? In our question, we're trying to find a critical value. Critical value. Whether that be a critical z or a critical t. And in order to use these, we have to be working from our data. Our distribution has to be approximately normal. Okay? So if they said, why do we have to go through the normal condition? You would say, to calculate critical values, whether they be critical z's or critical t's, we have to assume that the sampling distribution is approximately normal. Don't say normal. They don't want to say it. They want to say that the sampling distribution is normal. You want to throw in that approximately normal. That's big. Okay, I heard it on a thing I watched last night. I'm filming this on Thursday, and I watched something last night on Wednesday, about an hour training on this kind of stuff from our authors, did another one. So you would say approximately normal. Okay? So what do? This is what we do for the normal condition to satisfy the normal condition. Why do we do it? Because when we're doing a significance test or we're doing a confidence interval, we need critical z's and critical t's. And in order to use the critical z's and critical t's, we need to make sure our distribution's approximately normal. So that takes care of the R and the N, random normal. And now we're going on to the last part, and the last part is independent. Okay, so I'll do it right down here. I'm trying to save paper. I showed the people in the thing today how many papers. I went through almost a whole packet of paper. But this, I'm going to plant a tree in the summer to make up for it. So this is the independent condition. Okay, and sometimes they just call it the 10% condition. And what we want to make sure is that when you're sampling without replacement, that your sample size is less than or equal to 10% of the population. So if I went back to that example we just talked about of men in Massachusetts, you would want your sample size, let's say I took a sample of, 750 men, okay, and I wanted to see what percent of them liked pizza. Well, 750 is less than or equal to 10% of all men in Massachusetts. Okay, so that's what I would put down for the independent condition. So 750 is less than or equal to 10% of all men in Massachusetts. That would be a good statement for the independent condition. Now, if they say, why do we use the independent condition? Okay, and the reason that we have this independent condition is so we can use the standard deviation of a statistic. Okay? Okay, so we can use the standard deviation of a statistic. Our observations must be independent. Okay? So we've gone through these. Random, normal, independent. If they are giving you a confidence interval or a significance test and they want you to verify the assumptions or verify the conditions, this is what we do. Okay? If they ask you, why do we have a certain condition? Then this is what you do. It's unlikely that you're going to have to do both, and you don't want to put both. You're not trying to show off and say, oh, I know all about conditions, because guess what? If this is what they are asking for, and you did that perfectly, and you made a mistake with the explanation of why you're using it, then it's wrong. Okay? So you have to see what they're asking for. If they want to know what, show that the conditions are satisfied. If you're doing a confidence interval, if you're doing a significance test, then this is what we do. Okay? If it's a different question, they're saying the conditions have been satisfied. Why do we use the normal condition? Why do we use the random condition? Why do we use the independent condition? Then you would go into those explanations. Random, okay, because random samples will give us unbiased data. Okay, from a sample. And if we want to infer from our sample, from our data that we're creating from this sample about a larger population, then it needs to be a random sample. Okay, if we want to show cause and effect, it has to be a random sample. Normal. Okay, in order to use a critical Z or a critical T, we need to know that our information is approximately normal. Okay, again, that's why. And then why do we have the 10% condition? Why do we have the independent condition? So that we can use the standard deviation of the statistic. Okay, so this is all about conditions. I'm hoping it will help you. We're going to be doing more confidence intervals and significance tests down the stretch. And when we have to do that, this is in your plan part. Again, your plan. Okay, if you haven't done it in your state, you want to name your test. They call it test, even though it could be an interval. Name your test and then go through and verify or show how the conditions are satisfied. That's the plan part. Okay? What I think is going to happen here, if they have a 4-part question, they're going to ask you just the certain parts of it. And I think that for the do part, I think they're going to give you a p-value, and they're going to say, okay, here's your p-value. I want you to interpret that p-value, and then say what we're going to do with that. And that's where you'd look at your p-value if you're doing a significance test, and you'd match it up to alpha, which is 0.05, and say if it's less than that, we reject the null hypothesis. If it's greater than that, we fail to reject. And we'll have more videos about that as we go down the stretch as well. Okay, so this was all about conditions, important to review. Okay, hopefully it was helpful. If you have any other questions, please let me know.